Traditionally, you've got all these tractors and random width implements, so you're driving back willy-nilly over the field surface, trafficking probably 80 to 100% of the soil surface. It's doing a lot of compaction damage. With RTK satellite positioning, we can put everything repeatably year on year on year on year exactly in the same place. So once you're locked onto the lanes, which are in the computer on the tractor, it's just hands off and the tractor steers itself. But it also makes yield mapping and the soil zones and the variable rate seeding, it makes them more accurate as well.
Julian can use the satellite data to take raw information, raw images of single individual fields that we can then analyse, and from these key components you can actually start to really manage his estate in a better, more efficient way.
We use a variety of image processing within our organisation. The first we use is soil brightness mapping.
So effectively picking up the reflection of the soil, and so the darker ones are heavier soil types which are darker brown, and then the lighter colours are the sort of lighter soil types that reflect the light more.
The secondary use of satellite imagery is Ndvi, looking at the thickness of the crop, so how many plants you've got on the ground and the greenness of that plant. Green and thick indicates more nitrogen in the system or more moisture in the system, so you need to put less fertiliser on. Historically, farmers have been quite wasteful with their products, and even if the field didn't need it, it got it. And ultimately, if the field doesn't need it, you don't get any benefit.
When looking at it, we decided to do this Robin Hood approach, so we're going to give the poor areas more to get them started and get them growing up away from the pigeon damage, and hopefully they might catch up a bit, and we're going to give this good area of crop slightly less. Later on we might say, well actually, it's end of May now, these poor areas are never going to yield anything, we're throwing our money away, actually let's put less on them, but we stand a chance of getting a really good yield off this, so we might then do the King John approach, which is feed the rich.
Precision farming can help farmers reduce the potential pollution to hedgerows or watercourses by making sure that the chemicals, the fertilisers that they are applying are going on exactly where they should be going. We are seeing significant steps forward with yield, and to feed the growing population, the world growing population in future, technology has got to play a key role in doing that.
Forest research provides expert, independent research that goes towards the better understanding of our forests, both in terms of policy and practice, with the aim that it will enable forests to be managed sustainability for now, tomorrow and the future. And that is what drives us forward. We use a range of technologies and techniques. A lot of it is using historical evidence from up to 100 years ago. And we can use satellite technology to detect very quick changes in forests, about over a week or a month, as well as some of the long-term changes. We can use different techniques to tell us different things about tree condition, about forest health, but also the amount of wood that there is in the forest, as well as some really interesting things such as the archaeology and the drainage within a forest that you simply wouldn't see by walking through a forest.